Hello trigonometry students, welcome back. My name is Jami Emigh, and this is our third video for chapter 1. We're going to start with an example where we find the 6 trig function values for angles of 90 degrees and 180 degrees. Let's sketch the first one. It would look like this. Angle in standard position, so vertex is at the origin, initial side is along the positive x-axis, terminal side opens and stops, and this time it stops on the y-axis. In our previous videos and the homework you've done so far, the terminal side was between two axes. So it was in quadrant 1 or quadrant 2, quadrant 3 or quadrant 4. So when we have an angle that terminates on a axis like this, it's called a quadrantal angle. And we find the 6 trig function values the same way. We take any point on the terminal side. I'm going with 0, 1. If you want, you can go with 0, 2, or any point on this terminal side. As long as we don't make a mistake, we'll get to the right answer. All right, going with this point here, we have x is 0, y is 1, and where did this r come from? Well, we know that r is equivalent to the square root of the x coordinate squared plus the y coordinate squared, which would be the square root of 0 plus 1, which is square root of 1, which is 1. And we're only talking the positive root. Remember, r is always positive. Okay, check. Once we have x, y, and r, we can find our 6 trig function values. I am going to start with sine of 90 degrees. It is y over r, 1 over 1 reduces to 1. Then cosine of 90 degrees, which is x over r, so 0 over 1. Any quantity or no quantity in your numerator, so 0 in the numerator divided by anything is 0. Tangent next. Tangent of 90 degrees is y over x, so 1 over 0, and any quantity in the numerator divided by 0, it has an undefined value. Okay, let's go with the reciprocal function of sine, which is cosecant of 90 degrees, which is r over y, so 1 over 1, which reduces to 1. Of 90 degrees is r over x, so 1 over 0, which is undefined. And the sixth one, cotangent of 90 degrees is x over y, so 0 over 1, which is 0. Okay, let's try that again. Maybe if you feel up to it, pause the video and try to do the same thing for an angle whose measure is 180 degrees. All right, if we sketch that, it looks like this here. And to find the 6 trig function values, we just need to use any point on the terminal side. I'm going with -3, 0 this time. You can go with -1, 0 if you'd like. I just want to show that it doesn't always have to be something 1 unit away from the origin. All right, so using this point here, x is -3, y is 0. And we know that this r comes from the square root of the x coordinate squared. That'll be 9 plus the y coordinate squared, which is 0. And the square root of 9 is 3. So we have our x, y, and r. Let's plug those in. Sine of 180 degrees, which is our theta, is equivalent to y over r, so 0 over 3, which is 0. Cosine of 180 degrees is equivalent to x over r, so -3 over 3, which reduces to 1. Tangent of 180 degrees is equivalent to y over x, so 0 over -3, which is 0. Cosecant of 180 degrees is 3 divided by 0, so undefined. Secant of 180 degrees, 3 divided by -3, so -1. And cotangent of 180 degrees is -3 over 0, which is undefined. Okay, so let's go to the next slide. We're going to use this information to fill in a table on all the quadrantal angles. An angle in standard position whose terminal side lies along the x-axis or y-axis, such as an angle with measures 0 degrees, 90 degrees, 180, 270, 360, and so on, are called quadrantal angles. Use the values from the last slide and your calculator to fill in the table below. Make sure your calculator is set in degree mode. All right, so the title of our table is Trigonometric Function Values of Quadrantal Angles. Our rows are our angle measures of theta. So we're going with 0, 90, 180, 270, 360. So all quadrantal angles. And the columns, we're going to do sine, cosine, tangent. And check out column 4. It goes to cotangent next. So cotangent, secant, cosecant. So careful you fill them in the correct order. Okay, on the last slide, we did 90 and 180. So I'm going to do these two rows first. Okay, so on the last slide, I'm going to get, look at the 90-degree example. I'm going to find the values of sine, cosine, tangent, cotangent, secant, cosecant. Okay, going back one slide, that would be like this. 1, 0, undefined, then to cotangent next. 0, undefined, 1. Okay? You have this written down, so it should be a little easier for you, but I have to go toggle back and forth between slides. So 1, 0, undefined, 0, undefined, 1. So we've got 1, 0, undefined, 0, undefined, and 1. All right, we've got one row filled in. Let's do the same thing for the 180 degrees. Look at your last slide. Okay, values are 0, -1, 0, undefined, -1, undefined. Zero, -1, 0, undefined, -1, undefined. All right, we've got two rows filled in. So we can do examples where we sketch the angles of 0, 270, 360, find a point on the terminal side, and then do exactly what we just did to fill in these last three rows. Or we can use our calculator. Directions say that we can, and that's a good skill to have too. So let's turn to our calculator at this point. So take out your graphing calculator. All right, so I want to go with the top row here, which is 0 degrees. Okay, so sine of 0, well, I know I'm in degrees, it says it right here. If not, you change it in mode. If yours says rad, you're in radians, so hit mode and change it there. Okay, once you're in degrees, function is sine, input is the angle of 0, output is the value, 0. Cosine, input 0, output value of 1. Tangent is next. Tangent, input the angle 0 degrees. It will output a value of 0. Cotangent is next. And that's a problem because cotangent is it doesn't have a key for its function on the TI-84. So what I can do though is just use the reciprocal of tangent. So if I go 1 divided by tangent of 0, it'll give me the value of cotangent, which it says that there's an error, and that's because we're dividing by 0, which means that it's undefined. Okay, that's okay. Don't let this throw you off. It means that cotangent of 0 degrees is undefined. Okay, so I'm going to hit quit by just hitting enter. And that error right there, I know means undefined. Okay, so I've got the first 4. 0, 1, 0, undefined. And let me just write those in so I don't cover them up. 0, 1, 0, undefined. All right, next one is secant of theta. So I'm going to use the reciprocal function of secant, which is cosine. So I'll do 1 divided by cosine of 0, and that's going to output a value of 1. And the last one is cosecant. That's the reciprocal of sine. So 1 divided by sine of 0. Close, run it. and we have an error again, no problem. That just means that we've divided by 0, which makes it undefined. Okay, so the last two are 1 and undefined. Okay, our next row is theta equals 270 degrees. So we're going to go to our calculator again, and we need sine of 270, values -1, cosine of 270, value 0, tangent of 270, value is an error, domain error. Oh, okay, it doesn't say that the error this time is dividing by 0. So we're gonna have to look into this one. So we're gonna, no problem, we're gonna hit enter. But this time our error was a domain error, so it's not necessarily undefined. So I'm going to come back to tangent of 270. So let's do this. Let's fill in our -1, our 0, and we're gonna come back to this one, okay? No problem. Let's keep moving though. We'll need cotangent of 270 degrees. Let's see if we can get that. Divided by, that would be 270. This isn't going to give us a value either. Same domain error. No problem. We're going to come back to that one. All right, secant and cosecant. So that would be 1 divided by cosine of 270, dividing by 0. That one's going to be undefined. We're comfortable with that type of error. And then the last one, 1 divided by sine of 270. So we've got undefined and -1 for our last two. All right, well, that was actually a good lesson for us, because as powerful as our technology is, if we don't know how to use the specific technology that we are working with, it can lead us to false results. So when you choose your calculator, whatever graphing technology you're using, stick with it the whole class and practice with it as much as you can. All right, let's get this last row filled in, and then we'll come back to those two that our technology wouldn't do for us. So let's get sine of 360, and it's 0. Okay, I'm not sure I even need to type all these in, because 0 degrees and 360 degrees, those terminate at the same spot. So would these trig functions have the same values? Let's check a few more. Cosine of 360, 1. Tangent 360, 0, and see here it's matching up with our 0 degrees. 0, 1, 0, and we can, just to confirm, we can do the last three. So we'll do 1 divided by tangent of 360 to get our cotangent value. And sure enough, it says dividing by 0, so undefined, so that matches. 2 more, we need secant, so 1 divided by cosine. Is 1, and last one, just to confirm that 0 degrees and 360 degrees are going to have the same function values. That would be 1 divided by sine of 360, dividing by 0 error, so that would be undefined. So our last three would be undefined, 1 undefined. All right, let's see if that matches over here. Undefined, 1 undefined. Yes, so what we just learned is that the trig function values at an angle of 0 degrees are the same as the trig function values for an angle of 360 degrees, which if you sketch each one of those, you see that they terminate at the same location. All right, we have 2 left that we did not fill in, and that's because our technology didn't help us with that, at least the TA84 Plus. So let's figure these ones out by hand. So 270 degrees, tangent and cotangent. I don't have a lot of space, I'll just sketch it right here. I'm going to make this my X and Y axis. Standard position, so vertex, initial side is here along the positive x-axis. Terminal side opens, rotates 90, 180, 270. So stops here at a 270 degree, which is on the y-axis. Okay, so we pick one point, any point on the terminal side. I'm going to go with 0, -1. Okay, I'm going to go with x is 0, y is -1. In that situation, r would be equivalent to the square root of 0 squared, which is 0, plus -1 squared, which is 1. So r is the square root of 1, which is 1. Okay, now that we have x, y, and r, we can figure out tangent of 270 as well as cotangent of 270. Okay, tangent of 270 is the y-coordinate, which is right here, -1, divided by the x-coordinate, which is right here, 0. -1 divided by 0 is undefined. And cotangent. Cotangent is the x-coordinate, which is 0, divided by the y-coordinate, which is -1. 0 divided by -1 is 0. All right, so using our trig functions in terms of x, y, and r, as well as our calculator technology, we have calculating 3, 2, 1. All right, so using our trig function values in terms of x, y, and r, as well as calculating technology, we have found the values for these 6 trig functions at these quadrantal angles. Next, 2, 1. Now we're going to look at the trig function values of special angles. So we're going to start with a 30-degree angle. So given the unit circle where r equals 1, we're asked to find x and y on the 30, 60, 90-degree triangle. So that's why 30 degrees is a special triangle. There's this relationship between the sides that you may have studied in previous classes like geometry. So here we have a 30, 90, that makes this a 60-degree angle, so special triangle. This is a unit circle, so we know that the radius of the circle is 1, which turns out to be the hypotenuse of our triangle, or r equals 1. Okay, and now we are asked to find x, which is this side here, as well as y, which is this side length here. Okay, using some theorems that we have about an equilateral triangle, we can turn our 30, 60, 90 into a 60, 60, 60 triangle, 60 degrees, 60 degrees, 60 degrees. That makes it equiangular, which makes it equilateral. That makes all 3 side lengths 1 unit. So 1 unit, 1 unit, and this one here would also be 1 unit. And that leads us to the value of y right here, because this full side is 1 unit, y is half of that. So we just found the value of y. Now to find the length of this side of the triangle, represented by x, well, we know 2 sides, missing 1 side. In a right triangle, we can use the Pythagorean theorem. So that would be x squared plus y squared equals our hypotenuse squared. Plugging in our known values, we know that y is 1/2. We just figured that out, and we were told it's a unit circle, so r is 1. Now we're going to solve for x. 1/2 squared is 1/4. 1 squared is 1. Now we need to make some moves to isolate this x right here. Start by subtracting 1/4 from both sides of the equal sign. So now we have x squared is equal to 3/4. X is almost isolated, just need to get rid of this squared. We do so by square rooting both sides of the equal sign. Square root of x squared is just x, and the square root of 3/4 is radical 3 over 2. Now we introduced the square root into this problem, so we would want to consider the positive and the negative root, but we are only going to use the positive root because we're talking this side length here, so it's a positive for distance. All right, so now we have done what they asked. They asked us to find x and y on this 30, 60, 90 degree triangle. So we found that x is rad 3 over 2 and y is 1/2. Okay, so we're going to write that as a coordinate. So this point right here has the coordinate x, so rad 3 over 2, comma, y, which is 1/2. And now we can use that coordinate to find the trigonometric function values of this special angle 30 degrees. We know that sine of theta is equivalent to the y coordinate. So this information just told us that sine of 30 degrees is 1/2. We know that cosine of theta is equal to the x coordinate. So we just figured out that cosine of 30 degrees is radical 3 over 2. Now you might be thinking, isn't sine y over r and isn't cosine x over r? You are correct, but remember we're working with the unit circle here, so r is 1. So that would be y divided by 1, so 1/2, and x divided by 1, so it remains rad 3 over 2. Okay, so let's just write those out. We just found that sine of 30 degrees has a value of 1/2, and that cosine of 30 degrees has a value of radical 3 over 2. Now let's use that information to find the values of sine and cosine for different angles on this unit circle. I'm going to look at this angle right here. Okay, that would be the 180 degree angle, but I'm going to subtract out 30 degrees of it. I'm not going to go quite to 180 degrees. 180 degrees less 30 degrees gives us an angle of 180 minus 30, which is 150 degrees. So if we have this coordinate right here, beeline it to the x-axis like this, right triangle has been constructed, then we have similar triangles. They're actually more than similar, they're congruent. So this side length right here is radical 3 over 2, and this side length right here is 1/2. So the coordinate is going to be, well, just be careful. These side lengths are positive, but to get to that coordinate over here on the unit circle, we're going to have to travel in the negative direction on the x-axis and then the positive direction on the y-axis. So that's going to make this coordinate right here negative rad 3 over 2, comma 1/2. So what we just found is that sine of 150 degrees is also positive 1/2, and cosine of 150 degrees is negative radical 3 over 2. Let me just write that on there for us. This is sine of 150 degrees, and we also found cosine of 150 degrees. Let's do the same thing with using this congruent triangle right here, as well as the congruent triangle that we drew earlier. Okay, so the coordinate for this one right here, now remember we're in quadrant 3, so that's going to be negative in the x direction as well as a negative in the y direction. So this coordinate on the unit circle is negative rad 3 over 2, negative 1/2. And if we can find that angle, let's go to the initial side. open, 90, 180, plus 30 more, that gets us to the terminal side right there. 180 plus 30 degrees is 210 degrees. So we just found that cosine of 210 degrees is equal to negative rad 3 over 2, and sine of 210 degrees is equal to negative 1/2. One more. Let's find, well, we've got the coordinates for this point on the unit circle here. It's in quadrant 4, so it's positive rad 3 over 2, negative 1/2. Its angle measure would be, we need to start at the initial side and open 90 degrees, 180, 270, and we don't go all the way to 360. We're stopping 30 degrees short. So 360 less 30 degrees is a 330 degree angle. So we have found that cosine of 330 degrees is equal to positive radical 3 over 2, and sine of 330 degrees is equal to negative 1/2. All right, so just using this unit circle here, we have found the trig function values for sine and cosine for 30 degrees, 150, 210 degrees, and 330 degrees. And from sine and cosine, we can find tangent, cotangent, secant, and cosecant. All right, so let's check out a different special triangle called the 45, 45, 90, which we have here on the unit circle again. Our task is the same. We want to start by finding the values of x and y. So we have x and y. Okay, a 45, 45, 90 degree triangle is isosceles, and there is a theorem about isosceles triangles that say the sides opposite of the congruent angles are congruent themselves. So this side across from the 45, I'm going to put a single tick mark, and this side across from the 45, another single tick mark. That geometric code right there represents that the two side lengths are the same. Okay, so instead of calling them two different variables, x and y, I'm just going to temporarily call them both x. That will allow me to set up the Pythagorean theorem, x squared plus y squared equals r squared, with less variables. I'm going to change the y into an x, and I'm going to change the r into 1 because we're working with the unit circle. That looks like this here. Now that we have an equation with only one unknown, we can solve for x. So you'll want to start by combining like terms. So you have 2x squared equals 1, and then make some moves to isolate x. So divide both sides by 2 and square root both sides. We're talking side length, so we're only working with the positive root. Okay, this is the side length of x and y. However, we do not give our side lengths with radicals in the denominators. So the next step right here is just algebra. It's called rationalizing the denominator. This is not trigonometry part. This is just rationalizing the denominator. Multiply top and bottom by radical 2. And we get the same value, not changed, just written in what's considered more simplified because it does not have a radical in the denominator. Okay, so we have accomplished our first task, which was to find the values of x and y. So our side length here is radical 2 over 2, and this side length is also radical 2 over 2, making this coordinate right here positive radical 2 over 2, comma, radical 2 over 2. So we have found that cosine of 45 degrees is equal to rad 2 over 2, and sine of 45 degrees is also equal to rad 2 over 2. All right, we're going to do the same. Oh, let's write that out first. So here we've got sine of 45 degrees is rad 2 over 2, and cosine of 45 degrees is rad 2 over 2. Okay, let's do the same thing that we did on the last slide. Let's use this congruent triangle and this one. Whoa. And this congruent triangle right here. So we're really using the unit circle as much as we can to help us find more trig function values. Okay, so if this coordinate is radical 2 over 2, radical 2 over 2, then this coordinate right here would be the same, but we're in a different quadrant, so it's negative rad 2 over 2, positive rad 2 over 2. Moving here to quadrant 3, we have negative x and negative y, and last one here in quadrant 4 would be a positive x value and a negative y value. So if we can just find those angle measures now, we will know cosine and sine of 3 more angles. All right, let's start at the initial side and open 90 degrees plus 45 more. 90 plus 45, that gives us a 135 degree angle, making cosine of 135 degrees equals negative rad 2 over 2, and sine of 135 degrees equals positive radical 2 over 2. Let's find the next angle. Start at the initial side. Open 90, 180, and 45 more. That is a 225 degree angle. So we have found that cosine of 225 degrees is negative rad 2 over 2, and sine of 225 degrees is also negative rad 2 over 2. And one more. Go to your initial side. Open 90, 180, 270 plus 45. 270 plus 45 is 315 degrees. So we have found that cosine of 315 degrees is positive rad 2 over 2, and sine of 315 degrees is negative rad 2 over 2, all using the unit circle. All right, we're going to do this one more time. It's going to be with that same special triangle from before, the 30, 60, 90, except that we're changing the orientation. We're going to put the 60 degree angle here at the origin. Okay, so this is now our theta. So if theta equals 60 degrees this time, our side lengths are the same as they were before. This right here was 1/2, if you recall. And this one right here, if you recall, was radical 3 over 2. So making the coordinate right here, just showing the work for that if you want to. X squared plus y squared equals r squared. We had found that x in this case was only half. Okay, let me just elaborate on this work here. We, just like last time, would construct a equiangular triangle. So the 60, 60, 60. And if the entire side length here is 1, because it's the unit circle and that's the radius of the circle, then that side length right here is half of that, which is the 1/2. Using the 1 and the 1/2, plugging them into the quadratic formula, the Pythagorean theorem, we get that our y value is radical 3 over 2. So maybe you remembered those from 2 slides back, or maybe you want to work them out from scratch. Either way, they lead us to, I want to erase this triangle though, so it doesn't become distracting. All right, it leads us to this coordinate right here on the unit circle, which is 1/2 in the x direction, rad 3 over 2 in the y direction, telling us that cosine of 60 degrees is 1/2, and sine of 60 degrees is radical 3 over 2. We're going to do the same thing as we've done on the last two slides for this point right here, and this one right here, as well as this one right here. So if we go from this point, beeline it to the x-axis, we've got a congruent triangle. Same thing from here, beeline it to the x-axis, congruent triangle, and one more here. Okay, so that coordinate over here is going to be negative, just want to write those out first. Sine of 60 degrees is rad 3 over 2, and cosine of 60 degrees is the 1/2. That was just what we wrote here, but now it's written here for us as well. Okay, back to what I was saying. This coordinate on the unit circle is then negative y direction, positive x, because we're in quad 2. In quad 3, they're going to both be negative, and in quadrant 4, it's going to be positive, negative. Okay, if we can find those angles now, we'll have more of our trig function values. Start at the initial side, opening, we're going 90 degrees plus, well, how much more is that? We know that this is 60, and complementary angles here, because this quadrant has to be 90 degrees, the rectangular coordinate system, so this has to be 30 degrees here. So this would be 90 plus 30 more. That's 120 degrees. You could have also thought about it as you go past the 90, but you don't go all the way to the 180. You go 60 degrees less than that. So you could have gone 180 minus 60 to get you to the 120. That's fine as well. What that leads us to is cosine of 120 is negative 1/2, and sine of 120 degrees is radical 3 over 2. This one here, initial side, 90, 180 plus 60 more. That is 240 degrees. So we have found that cosine of 240 degrees is equal to negative 1/2, as well as sine of 240 degrees. We found that to be equal to negative radical 3 over 2. And last one, initial side, 90, 180, 270 plus 30 more, because we're shorting ourselves these 60 degrees. So what was that? 270 plus 30. So that is a 300 degree angle. So we found that this tells us that cosine of 300 degrees equals 1/2, and sine of 300 degrees equals radical 3 over 2. All right, the next slide is going to show us everything we've done with the unit circle all in one picture here. This is the function values of quadrantal and special angles using the unit circle. So we've got cosine at 30 degrees, sine at 30 degrees, same for 45, same for 60 degrees. We also have the quadrantal angles added on here, so 90 degrees, that gives us our cosine value. The x-coordinate is always cosine, so cosine of 90 is 0, sine of 90 is 1, and then as we continue around the unit circle, we have cosine and sine values for 120, 135, 150, adding this quadrantal angle of 180, 270, 225, 40, quadrantal angle of 270, followed by 300, 315, 360, and back to our quadrantal angle of 0 or 360 degrees. So the unit circle is a very useful tool in finding the exact function values for these particular angles. Remember, these are the special angles, 30, 45, 60, and then they're congruent triangles in every quadrant, as well as the quadrantal angles. All right, I want to take the unit circle now and put it into a table format. So if you go to your next slide, we have the function values of quadrantal and special angles using the table. Okay, looks quite different and actually has some additional information on it for us. The unit circle on the last slide only had sine and cosine. So the unit circle on the last slide gave us all just degrees. So the unit circle on the last slide gave us this information right here. Okay, 0 degrees, and then we traveled around the unit circle. 30, 45, 60, first quadrant. 120, 135, 150, 180, quadrantal angle. 210, 225, 240, 270, quadrantal angle. 300, 315, 330, and then that would bring us back to 0 or 360 degrees. Okay, these are all degrees. If you want to add those, your column is titled degrees, but sometimes it's nice to have that information all in one cell. Okay, the unit circle also gave us coordinates. So the x coordinates were all the cosine of theta values, all listed here. These were all the x coordinates you saw in the unit circle, and these were all of the y coordinates that you saw in the unit circle. Okay. Now, where does the rest of this information come from? Well, we know that tangent of theta is equivalent to the y coordinate divided by the x coordinate. So if you went back to your unit circle, or actually it's right here, if you take your y coordinate, so 0 divided by your x coordinate 1, it'll give you your function value for tangent, which is 0 divided by 1 is 0. And cosecant, we know, is the reciprocal of sine, so that's going to be 1 over y. That's because we're talking the unit circle, okay? Not r over y. Well, it is r over y, but r is 1. So 1 over y, so 1 over 0, undefined. We know that secant theta is, using the unit circle, 1 over the x coordinate. Okay, so 1 over 1. 1 over 1 is 1. And cotangent, we know, is the x coordinate over the y coordinate. So that would be 1 divided by 0, which is undefined. So by just knowing sine and cosine, it leads us to tangent, cosecant, secant, and cotangent function. Now we're going to stop the video and do more homework in my lab and mastering. Let's see, we left off on, you should have completed chapter 1 homework question number 27 already. So now we want to do homework chapter 1. Let's do numbers 28 through 38. All right. Thank you for being here. My name is Jami Emigh, and I will see you next time.